a line segment has one endpoint and it's at -3, and the midpoint of the line segment is at 3.5, where is the other endpoint? So again, let's take a look at our number line. The question told us that one endpoint is at -3. Let's call this A. The midpoint is at 3.5. If 3 is here, 3.5 is going to be halfway between them. So 3.5 is approximately here. And that's the midpoint, so we'll call that M. So first thing we have to do is find the length, the distance, from A to M. A is at -3, and M is at +3.5. So here we get the absolute value. Keep the sign of the first, change it to addition, change the sign of the second. And this is going to give us -6.5 in absolute value brackets, which means the distance from A to M is a +6.5 units. Since the distance from here to here is a +6.5 units, and M is the midpoint, that must mean that B, the other endpoint, has to be 6.5 units away from M, which is at 3.5, which means that B must be at +10, which would be about here. Find PQ. Since there's no line above it, this is asking us to find the distance of PQ. Well, you can see you have -4 and -2. In cases that are simple like this, you can count 1, 2 units away. So here PQ is 2 units. PR, 1, 2, 3 units away. So PR is 3 units. QR, 1 unit away, 1 unit. RS, 1, 2, 3 units away. PR, 1, 2, 3 units away. QS, 1, 2, 3, 4 units away. And PS, the whole segment, 1, 2, 3, 4, 5, 6 units away. And again, you can use the distance formula here. You can do the measure of PS, the absolute value of P minus S, and you should get the same answers. Now part B is asking to find the midpoint of PS. That means midpoint would be P plus S divided by 2. So the midpoint would give you -4 plus 2 divided by 2 is -2 divided by 2, which means the midpoint is at -1. Well, here we can see R is at -1, so the midpoint of PS would be point R. Lastly, part C is showing you PQ plus QS equals PS. So it's asking you to prove the segment addition postulate. So we need to find the measure of PQ, the measure of QS, and prove that it does in fact equal the measure of PS. So first, the measure of PQ we said was 2. The measure of QS we showed before is 4. And the measure of PS we saw as 6. 2 plus 4 is 6. 6 does equal 6. so you can show that that is true. And again, you can use the formula that we used before to find the distance on a number line, or you can count the spaces in between. Just make sure that the number line is counting by whole numbers before you start counting on the number line. The last question on this page is saying Q is the midpoint of PR. So we can see here Q is in between P and R. It's the midpoint, which means this segment is congruent to this segment. The question is asking for PQ, QR, and PR. Well, if this is the midpoint, what do we know about PQ and QR? We know that from the picture, PQ is congruent to QR. And by definition, the midpoint cuts it into two equal parts, which means the measure of PQ must equal the measure of QR. This means that 6x minus 7 must equal 5x plus 1. From here, we can solve for x. Subtract 5x from both sides. You get x minus 7 equals 1. Add 7 to both sides, which means that x equals 8. If x equals 8, this means 6 times 8 minus 7. 6 times 8 is 48, minus 7 is going to give you 41. 5 times 8 plus 1, 5 times 8 is 40, plus 1 is 41. They should obviously be the same amount of units because they are congruent pieces. Each of the pieces are 41 units, which means the total PR is going to give you 82 units.